Hi guys, this is Mr. Holly. We're looking at lesson 6 in your notebook today. As you can see, I'm already on the problem set. So if you go ahead and skip over to the problem set, that's what we're going to use for our instruction today. This activity for today is actually a little more project-based. So I will do the problem set to show you how it's done, and then you can do the actual project, the activity, on your own for your practice. Okay? This question is a little wordy. I'm going to read it to you. If you'll just be patient with me. Sally's aunt put money in a savings account for her on the day Sally was born. The savings account pays interest for keeping her money in the bank. The ratios below represent the number of years to the amount of money in the savings account. After 1 year, the interest accumulated and the total in Sally's account was $312. So these are my ratios. 1 year, $312. After 3 years, $340. 6 years, $380. 9 years, $430. 12 years, $480. Okay? Now, let's see what the question asks. Using the same fourfold method from class, this is the method that you'll actually use to practice after we're done, create a table and a graph and explain whether the amount of money accumulated and the time elapsed are proportional to each other. Use your table and graph to support your reasoning. So what is our problem asking? It's asking, is the time elapsed proportional to the money accumulated, or we're going to use the word saved. Is the time elapsed proportional to the money saved? So is there a proportional relationship between the time that has passed since Sally's been born, since her bank account started, and the amount of money she has? And we're going to use a table to do that. We're going to create a table over here, and we're going to use X and Y. We're going to make time our X variable, time, and Y is going to be our money, the amount of money she has. After 1 year, she has $312. After 2 years, or excuse me, 3 years, let me erase this. After 3 years, she has $340. After 6 years, she has $380. After 9 years, $430. After 12 years, $480. Okay, so these are my amounts. Now, I need to graph them on a graph. One of the things that I find students struggle with is whenever we're graphing large amounts like this and you're given just a blank coordinate plane, kind of at a loss. This is essentially going to be a 20 by 20 coordinate plane. How do I fit numbers like 480, 430? How do I fit them on there? So first of all, this is kind of a poor copy, so we're going to cut this off right here. This is going to be 0. This is going to be our x-axis, okay? Now, the way I would go about labeling this graph, and it goes to 15 on the x-axis, I would look at my x variable. It goes to 12. That will fit perfectly. So this can be 1, 2, 3, 4, 5, that's 10, that's 15. Okay, that fits perfectly. Now I need to figure out, how am I going to fit money on there? Well, it goes up to 480, so I probably need to go up to at least like 500, right? So if I have 20 spaces, and I need to go up to 500, maybe each of them could be worth 25. 20 times 25 is 500, so this would 5 spaces would be 125, 10 spaces would be 250, 15 spaces is 375, and now that's 500. So every box here is going to be worth 25 apiece. I'm going to be able to fit all of my data into this graph. Again, this is my x-axis, or my time, and this is my y-axis, my money. I want to label that graph. Okay? Now, I think I have a graph that's going to work, a structure that's going to work for me to fit my table onto my graph. Now, first point was 312. So 250, 275, 300, not quite 325. So that's going to put me at 312. Next, I have 340. So that's going to go, that is 325, that's 350, so just less than 350. 6, 380. So 6 is the one right after 5. Come up here to 375, and then it's going to be just above that. And 9, 430. So go to 9, and then let's go to 430. So 375 is this line. That's 400, 425, just above 425. And 12, 480. So that's going to be, this is 475, just up a little bit above that is 480. Okay? Now, my goal is to take this graph and this graph and this table, and we need to decide if this is a proportional relationship. We have the data we need now. We have the information in front of us. Now we can check to see, is it proportional? Well, we learned last lesson, lesson 5, there are 2 criteria that make a relationship proportional. 1, the graph must be a straight line. This graph appears to be pretty straight. I'm not sure that it's straight, but it's pretty straight. We'll talk about what makes it straight or not straight in just a minute, but it's pretty close to straight, okay? But not only does it have to be a straight line, but it has to go through the origin, or 0, 0. So in order for it to be proportional, it has to be straight, a straight line, and it has to go through 0, 0, or the origin. And because it does not meet this criteria, it is not proportional. So let's come over here. We're going to say the line is not proportional or I don't like the way I said that. I don't want to say line. Can we just go back in time about 10 seconds here? The relationship is not proportional, comma, because the graph does not go through 0, 0. Now, we can actually look at this table and we can determine that it's not proportional from the table. Go back to our first 4 lessons where we talked about determining if something's proportional based on the table. Remember, we would have to do y over x to test to see if something was proportional. 312 over 1 is 312. 340 over 3 is going to be roughly 100, less than 115, 110, 115, somewhere in there. So we're looking at that as like between 110 and 115. Obviously, that's not going to be the same amount. That's not going to work. Those are not proportional amounts. Come down here, 480 divided by 12. That one's actually kind of easy. 480 divided by 12, that's 40. So this is 40, this is 312, this is 110, 115 or so. Y over x is not giving me a constant, and that means it's not proportional. So I could actually add another sentence. The relationship is not proportional because the graph does not go through 0, 0, and the table does not have a constant value when y is divided by x. There's no constant there. Now, I'm going to kind of push this a little further just because I think this is interesting. It's a little beyond our lesson though. Is this a straight line? And here's how you could tell, and I'm just going to kind of show you quickly. In order for it to be a straight line, it has to continue to be increasing at the same rate. That's what makes a straight line. It continues every time we go over to the right 3 spaces, it goes up in the y-axis the same amount each time or so. So we're making equal jumps to the side and up, going over and up at the same rate. Well, here we see that as this goes up, it goes up by 40, and then here it goes up by 50. And because it changes at a different rate, like this is going up 3 and this is going up 3, so the x is increasing at the same rate, but the y is increasing at different rates. This is actually not a straight line, so that also could go into our explanation. That's not something you should be able to recognize yet, unless we had a more precise graph. But we could also include in our explanation, not only does it not go through 0, 0, it's not a straight line either. So this is not a straight line. It doesn't go through 0, 0. The table does not provide a constant when I do y divided by x. So I've got several different things that show me not a proportional relationship. So this serves as a non-example. That's good, but I think you need to see an example of what a proportional relationship looks like in order to do this well. If you go back to lesson 5, number 3 in your problem set, I'm going to do this one for you very quickly. I'm just checking our time. Yeah, we've got 3 minutes. Okay, so very quickly. If x is 3, y is 1. If x is 6, y is 2. If x is 9, y is 3. And if x is 12, y is 4. Makes a straight line. Remember how I showed you that earlier, that, or kind of explained that in the last one, that every time I go over 3 spaces, I go up 1 space. That's how I know that that's a line, because it's continuing to change at the same rate. And I can test over here in the table. This is 1 divided by 3, 2 divided by 6, 3 divided by 9, 4 divided by 12. Every one of these is going to equal 1/3. So I have a constant. Goes through 0, 0. It's a straight line. All the criteria checks out. That's proportional. Okay, so as you complete your work today, what you're going to be doing is taking some different problems. You're going to make a table. You will have some different examples to choose from. You'll pick one. You're going to come in here and you're going to fill out this 4-square grid here. And you're going to rewrite the problem, create a table, graph it, and then you're going to explain whether or not the relationship is proportional. All right. Thanks, guys. I hope this helped. Reach out if you need any more.